Okay students, now we can do some exercise problems given in the kinematics lesson. So see problem number 4. So already 1, 2, 3 problems I covered in the concept. Now problem number 4. So that is a boy moves 3 kilometers along a straight line. So he is walking 3 kilometers. 3 kilometers along a straight line. 3 kilometers along a straight line we told. So a boy walks 3 kilometers along a straight line and then takes left turn through 90 degrees and moves another 4 kilometers. So after that, so left turn he is taking, left turn 90 degrees, with an angle of 90 degrees, and moves another 4 kilometers. Moves 4 kilometers. So moves 4 kilometers. Find the magnitude of displacement. That's a question. Now the question is magnitude of displacement. So we have to find magnitude of displacement. So question mark is magnitude of displacement. This is we are going to find. Now see 3 kilometers along a straight line. So he is 3 kilometers along a straight line. Take 3 kilometers along a straight line. So then left turn. So at this position, if you consider like this will become the left turn by 4 kilometers. Left turn by 4 kilometers. Left turn by 90 degrees moves 4 kilometers. So this is the initial position. Let it be started at A. That is O he started. 3 kilometers he moved straight. And then from A to B 4 kilometers, so he went. So 3 kilometers line segment should be less than the 4 kilometers line segment. So because this is 4, it should be more. Okay. Now magnitude of displacement. So this is the path he followed. But displacement means what? Initial position, initial point and final point. Irrespective of the path followed by the man, just you join from initial position to final position. This will become the displacement. This is the displacement. Its magnitude we want. Means magnitude of displacement means our question mark is OB. Question mark is OB. Now by Pythagoras theorem we will write by Pythagoras. What is that? Pythagoras. So by Pythagoras theorem we write, what is that? By Pythagoras theorem we write hypotenuse square. So this is 90 degrees they gave. This is 90 degrees they gave for us. So 90 degrees they have given. So the side opposite to 90 degrees is called hypotenuse, we know. This is the hypotenuse. This is one side and this is another side. So by Pythagoras theorem, hypotenuse square. So hypotenuse square is equal to what will write, students? Side square plus, so hypotenuse square equal to side square plus side square. Hypotenuse square means OB square. OB square equal to one side, that is what is that? OA square plus another side, what is that, students? AB square. Then we want OB, so that is root over OA square plus AB square under root. So this OA means 3 square and AB means 4 square under root. So 3 square means we know 9, 4 square 16. So this is 25, root 25 means, so 5 meters is the answer for this question. So next problem we can see. So see 3 kilometers forward, left turn 4 kilometers and reach it to here, and we know 3, 4, 5 is a Pythagoras triplet. These are in kilometers, 3 kilometers, 4 kilometers, so this will be also in kilometers. So the magnitude of displacement will be 5 kilometers. Okay students, see problem number 5. A boy moves 10 meters, that is 30 degrees north of east, and 10 meters due south, and then 10 meters, and next 10 meters 30 degrees north of west. Find the magnitude of displacement. This is the question mark. So now we have to find the magnitude of displacement. And now we know the geographic directions, my dear students. We know the geographic directions class video. In the directions class video we have seen the directions. So now for this purpose, so take this is east, west, north, south. Okay students, now I am taking those for our clarity. Now this is the north, and this is east we know, and this is what, my dear students, west. So west. Okay, we got like this. Okay, fine. Now see, first 10 meters, 30 degrees north of east. First 10 meters in the northeast plane and making 30 degrees with east. See what is the final direction here. With that, this angle we should consider. So now, so 10 meters is the distance covered. 10 meters is the distance covered by making an angle of 30 degrees with the east. And at this immediate point, again you take the geographic directions. At this immediate point, again we will take the geographic directions. Now this will become the east, opposite of that west. This will become north, and this is the south we know. And now next 10 meters due south. Next 10 meters due south means again he is coming downward. That is called next 10 meters. He is coming to the south. So the next 10 meters south direction. So this next 10 meters south I have taken. And again at this immediate point, again you take the next immediate surroundings. Take the next immediate surroundings, and then 10 meters, that is 30 degrees north of west. And the next 10 meters, that is 30 degrees north of west. So again if you take the immediate, what is the geographic directions, this will become east, west, north, south. So now he is moving in northwest. So that is 30 degrees north of west. He is telling you here 30 degrees north of west. So northwest, this is 30 degrees north of west. So 30 degrees north of west. So 30 degrees with the north of west means, see this arrow tells where it is. So at that initial point we have to consider the directions. At this point you consider the directions. So at this point you take the immediate geographic directions. So it is in northwest only, and that is also nothing but this is in northwest. and with the best it is making how much angle? See students, 30 degrees it is making. This line and this line are same, my dear students. Okay. Now you know this is 30 degrees means this is also 30 degrees because these two are vertically opposite angles. Vertically opposite angles are equal. So this is 30 means this is also 30. 30 plus 30 60 degrees you will get. Then this is 90 degrees. Okay students, if I consider this is a triangle, if I consider this is a triangle, in this triangle we have here 30 degrees, we have here 90 degrees, then this will become 60 degrees. So see my dear students, this is 90 plus 30 120, 120 plus 60 180, so it will become a triangle 180 degrees. Sum of interior angles of a triangle is 180. And now similarly you see this is 30 degrees, this is perpendicular, so this is 90, this is 30 degrees, this is 90 degrees, so rest of this angle is 60 degrees. So this is 60, this is 60 degrees, and this completely 60 degrees. Means in this triangle all interior angles are equal. In this triangle, in the triangle all interior angles are equal. In the triangle all interior angles are equal. In the triangle all interior angles are equal, you know. So all interior angles are equal means all are making all interior angles are equal, that is 60 degrees. So all angles are equal means all sides are also equal. So all sides are equal by the triangle property we will get. So all sides are equal you are getting. Now see 10 meters, 10 meters, 10 meters. So initial point is this one and final point also this is only. So initial point and final point are coinciding. So displacement is 0. The magnitude of displacement will become 0. The magnitude of so magnitude of displacement is 0 we can write here. So the answer is magnitude of displacement is 0. So the answer is magnitude of displacement. So the answer is magnitude of displacement is, so that is modulus of S bar is 0. You can write. So magnitude of displacement is 0 since magnitude of displacement is 0 since initial point and final point are coinciding. Since initial and final point, since initial point and final point are coincides, so there is no shortest distance. The magnitude of displacement is 0. What is the magnitude of displacement in this problem is modulus of S bar is equal to 0. We can take it. And for the same problem, if they ask you the distance, if they ask the distance, so 10 meters like this, 10 meters like this, 10 meters like this. Total distance traveled 10 plus 10 plus 10. The total distance traveled you see 10 meters plus 10 meters plus 10 meters. So this is the total distance traveled. So it will become 30 meters. So the total distance traveled is 30 meters. Okay, see problem number 6 students. A person walks 12 meters towards north, 12 meters towards north, and then 4 meters towards west, and there he climbs a pole of 3 meters. He climbs a pole of 3 meters height. The total distance traveled by the person is the question mark. So what is the total distance traveled by the person? So person walks 12 meters towards north, 12 meters towards north, and then 4 meters towards west, and there he climbs a pole of 3 meters height. So the question is, the total distance traveled by the person is. Now, so total distance, answer. Total distance traveled, we want total distance traveled. Total distance traveled is equal to total distance traveled is S. Okay, denote the letter S. Then that S is equal to, what is that? Length of path traveled. So that is S is equal to length of path traveled or covered. Length of the path traveled. Length of the path means first 12 meters, and then 4 meters towards west, 4 meters towards west, and there he climbs a pole of 3 meters height. So, and from here 3 meters height of the pole he covered. So what is the answer you will get? 12 plus 4 plus 3. So 12 plus 4, 16, 16 plus 3. So the answer is 19 meters is the total distance covered. So the answer for the total distance is 19 meters. And for the same problem, in the above problem, they ask you the total displacement. So what we will do? So now see what they are asking students. For the same what is that problem, in the above problem, total displacement covered is the question mark. So total displacement question mark I want. Okay, total displacement means we have to take the geographic directions. So I am taking the geographic directions. Or see students, this is east, you know, west, north, south. Now a person walks 12 meters towards north. A person walks 12 meters towards north and then 4 meters towards west. That's the question now. Now it will be like a cuboid we will get. It will be like a cuboid we will get. See my dear students. So a person walks 12 meters towards north. So 12 meters north he went. So, and we can do the same problem with vector algebra also. So, but we want to do this problem here by using, we want to do this problem by using the horizontal directions. Horizontal directions. Now, here see, this direction I am taking as the east. This is the east direction I am taking. Okay, and this is the north direction I am taking, and this is, okay, that is vertically up for this plane. In this plane, this is the east, this is the north, means upward is north, downward is south, and this side is the east, this side is the west, and vertically up means out of the, this is vertically out, and vertically in means this, in this horizontal plane. Now see students, a person walks 12 meters towards north. From here to here, this is the north direction. So he covered 12 meters towards the north, and then 4 meters towards the west. And from this point, west means this side, no? Here he took turn, and how many meters students? 4 meters towards west, and 4 meters towards west. If I consider this is 12, this is 4. And he climbs a pole of 3 meters height. From there, he climbed a pole of 3 meters height. That is, this is I am taking. So he climbed a pole of 3 meters height. Means he started at A, reached to B, B to C, so reached, and C to D. These are the points he covered. A to B he went, B to C, C to D, means at this vertex of the cube he started, and the opposite vertex of the cube he reached. So if we consider, this is the length, and this is the breadth, and this is the height. If I consider LBH like that, then the diagonal of the cube is the displacement. So this is the initial point and this is the final point. So we know that definition of displacement, the line joining the initial point to the final point is called what you know, displacement. So the line joining from initial point to final point is called displacement. That's why from here to here this is called the displacement. So AD, so that is a diagonal. AD, that is a diagonal of the cube. AD is the diagonal of the cube. So which is the displacement in this situation? It is the displacement. AD is equal to length of diagonal of the cube. So length of diagonal of the body. Length of diagonal of the body of the cube. So this diagonal length I want. This is called the displacement in this situation. This is called displacement. This is called displacement in this situation. So the displacement is the diagonal of the cube. D is equal to, we'll get root over L square plus B square plus H square. So that is under root. L square plus B square plus H square. So L square means we have 12 square plus B square means we have 4 square plus H square means we have 3 square. So under root 12 square means 144 plus 4 square means 16 plus 3 square means 9. Okay students, then 144 plus 16, so that will become 160. 160 plus 9, 169. So that is called, so 13. So the answer is 13 meters is the displacement. So what is the net displacement in this situation means 13 meters. And we can see the next problem. Okay, students, now see, a boy starts from P and reaches S, started at P and reaches the S. So, a boy starts from P and reaches S along the path, that is called paths, along the path shown in the diagram, that is called paths, as shown in the figure. So now the distance travelled by the boy is question mark. So then what is the distance travelled by the boy is the question mark we have to find. Okay, see, the boy starts at the P point, P to A to T he travelled, T to H he travelled, and H to S finally he reached. So that is, if you add all the points what he has covered, that is from P to A to T, T to H, H to S, that is called paths. P, A, T, H, S paths he has covered. These are the paths he has covered. Clear? So now the question mark is the distance travelled by the boy. So distance covered by the boy I want. So I should write here distance. So we know that distance is the actual length of the path covered. That is called actual length of the path covered. So actual length of path covered, actual length of the path covered by the boy. So distance means actual length of path covered. Actual length of the path covered means, see students, see my dear students, he started at P and reached to A, means he went from total distance S is equal to, he went from P to A, that is called PA, plus P to A PA, and A to T he travelled, that is called AT. So next path covered is T to H he covered. So next path covered is T to H he covered, and next covered is from H to S. Okay, next covered is H to S. These are the paths he covered. Okay, now see my dear students, P to A means he covered 40 meters. P to A he walked 40 meters. Then A to T he went, that is 20 meters. A to T 20 meters. And T to H again 20 meters he covered. Plus H to S just 5 meters. So this is the total distance he covered. How he has moved we don't mind it. How he has moved we don't mind it. How much distance he walked, how much length he covered we will see. We know very clearly from the definition of the distance. So he went from P to A to T, T to H, H to S. So add all the distance, 40 plus 20, 60. 60 plus 20, 80, 80 plus 5, so the distance is 85 meters. So this is the length of the path he covered, that is the distance. So now you see my dear students, in the above problem displacement they are asking. So that is, now that's a problem number 9 it will become. So in the above problem, so that is the above problem means this is only the problem, and that is the things given. So starts from the displacement, and displacement is question mark. The displacement is the question mark that we are going to calculate. So now I want to find the displacement in the situation. Displacement means what? Displacement we want. Displacement, you know the letter S bar, because it has a direction, you know. So means we know from the definition of displacement, this is the initial point and this is the final point. Irrespective of the path followed by the person, remember very clearly students, irrespective of path followed by the person, the line joining from initial point to final point, the direct line segment joined from initial point to final point, that gives the displacement. So this is called, this point is S and this is called displacement. And this is called displacement. So here the displacement means P is the initial point and S is the final point. So PS bar is the displacement that we are going to calculate. Okay students. So displacement we want to find now. And see, this point is S we know. This point is S we know. This is the point S. And if I take one horizontal line here, this is 5 meters. So this is also 5 meters. This is also 5. Means this should be 15 meters. This is 15 we know. This length is 15 meters. And we know this is totally 40 and this part is 20. So the rest of this part will become 20 meters. Rest of the part is 20. Okay students. Total distance is 40 and this is 20. So the rest of this distance is 20. This is 20 and this is 15. So I want this. Let it be some, this is the perpendicular. This is some point I. So now this is the 90 degrees. It's a right angle triangle. So then this is the hypotenuse. So hypotenuse square. So hypotenuse square equal to what you write children? Side square plus, so side square plus side square you will write. Side square plus side square. One side is how much? 20. You write this 20 square. And next you write another side, that is 15 square. Then here you want what students? PS. Hypotenuse square PS. PS is our displacement. Then PS is equal to root over 20 square plus 15 square. So 20 square means 400, 15 square means 225. Then you will get 625. Root over 625 is 25 meters is the displacement in this situation. So displacement means PS bar. So the question mark for this you are getting 25 meters. And next one, and in this same problem, find the maximum displacement they are asking. In the same problem, they are asking to find the maximum displacement. So now the question is as shown In figure, find the maximum displacement. Maximum displacement is the question mark. He started here, and for this diagram, maximum displacement we are going to calculate. Okay, students, now you see so now our task is this point is S, we know this is the S, maximum displacement for the given diagram. Maximum displacement for the given diagram means from here to here you will get 40 meters. And here to here we calculated 25. Here to here we get more than 25. But if for this given diagram, if we join from P to T, this PT will become the maximum displacement. So PT so length of PT is in a specified direction. See, this is the initial point and this is the final point. We started here and we reached to here. This PT is the final, the length of PT, that is called, what is that, my dear students? That is called maximum displacement. That is called maximum displacement. So length of PT we want to find that PT, again this is the right angle triangle we have here. This is the right angle triangle. So PT square is equal to longest side square, hypotenuse square is equal to side square plus side square. So means we'll write PA square plus TA square. Then PT is equal to PA whole square plus, what will you write, my dear students? TA whole square under root. Okay, then PA square, its length we know, PA square length we know 40 meters. So 40 meters whole square, and TA square length is 20 meters. 20 meters whole square, keep under the root. 40 square means 40 square is 1600 plus 20 square is 400. So the length of PT is the maximum displacement, that PT we want to find. 40 square 1600 plus 400, so it will become 2000. So root 2000 value I want now. Root 2000 means I write this as 20 into 100. So 20 we can write it 4 into 5 into 100. 4 means we can write 2 square, or see students, 2 whole square into 5, write it as 5 only, 100 write it as 10 square, and 4 root, 2 square out of the root 2, 10 square out of the root 10, then 20 root 5 you will get. So 20 root 5 meters is the maximum displacement in the given problem. So 20 root 5 meters.